Hello everyone, and this is physics. In this video, I'd like to talk about Sir Isaac Newton, the Principia, and Newton's first law of motion. Now you might ask yourself, how do we know what scientists did in the past? How do we know what experiment, what discovery needs to be credited to a specific individual? Well, the answer to that is scientists publish their works. And this publication of their discoveries has been going on for thousands of years. In this book, there are many authors, such as Pythagoras, Plato, and, Sir Isaac Newton himself. And there's comments in here regarding Lord Kelvin and Niels Bohr and others. And their theories and ideas, they publish them. And the idea of publishing this is for other scientists to then to look at it. And so say, in the case of Isaac Newton, he publishes a particular item, says, I performed this experiment. Then others get a chance to do that same experiment and repeat it over and over and over again. And then they can say, yes, what he has written here in his publication is correct. This is known as peer review. Now, this peer review still goes on today. Scientists, even today, are still making discoveries. And they're publishing their work on a regular basis in magazines such as this, Astronomy, or in Discovery. And here's a picture of Albert Einstein. He did the same thing. The reasons we know what Einstein did is because he published his works. And my favorite magazine here, Scientific American. And it talks about finding life on another planet. And I assure you, if anybody ever finds life or on extraterrestrial planets, that will become front page news around the world. Isaac Newton was fully aware of these publications, and he also knew that he needed to publish his works, and he did, in a publication called the Principia. Now, the Principia itself has a rather large title. It is Philosophiae Naturalis Principia Mathematica. Mathematica because, Isaac Newton was first and foremost a mathematician. Here is the front page copy of the Principia. And it goes on. This particular page here says this is the third edition of the Principia. And as I read it, I've noticed that it's all in Latin. Oh my God, why is it all in Latin? Turns out in Newton's time, in his day, the language of science was Latin. The way scientists communicated to each other was through the language of Latin. So Isaac Newton printed his works in the Principia in Latin. And before I go further into the Principia, one of the discoveries that Newton wrote here within the Principia is about calculus. And Newton is generally regarded as the inventor of calculus. Let's have a look. Here is the calculus textbook. And within this calculus textbook has a little blurb here in the beginning regarding Isaac. And here's a picture of Sir Isaac Newton and a little bit of story about Sir Isaac Newton. And it mentions here, and I won't read the whole thing, so I'll just skip a little bit, go ... It says, during this time, he invented the calculus. Now, Isaac Newton didn't invent all of this. He invented the beginning of calculus. Others then took over and, of course, expanded on the works of calculus. And hence we have this textbook. During his time, there was another individual by the name of Leibniz. And Leibniz also discovered calculus. And Leibniz published his discoveries in calculus 2 years before Sir Isaac Newton published his Principia. And then there was an argument. Who was it that discovered calculus? Was it Leibniz or was it Newton? We look here in a more recent calculus textbook. This one dates to the 1990s. The prior one was somewhere in the 1960s. And if I look in here, and that discussion between Leibniz and Newton carried on, and there was a comment here, and I won't be able to read that exact comment, so I wrote it down. Here it is. In that textbook, there's this comment right here. It says Sir Isaac Newton and Gottfried Leibniz independently discovered the connection between derivatives and integrals and are both credited with the invention of calculus. So in today's textbooks, both individuals, Sir Isaac Newton and Leibniz, are given credit for the invention of calculus. Moving on to Newton's first law of motion. Within the Principia are Newton's three laws of motion and gravity and many other items. In particular, what we're talking about today is Newton's first law of motion. And this is written in the Latin. So in the Latin, if we take the Newton's first law of motion and translate it into English from the Latin, this is what it looks like. Every object continues either at rest or in motion in a straight line unless it is forced to change that state by forces acting on it. Newton's first law of motion, translated from the Latin. There are various other ways of saying this in modern English. Behind me are a variety of textbooks, and each one of them will state this in slightly different ways, and I am no different. So let's look at Newton's first law of motion. It says here, every object continues either at rest, and I call that part A. And it goes on, it says, every object continues in motion, and I call that part B of Newton's first law of motion. So actually, Newton's first law here has two parts to it, an item at rest or an item in motion, part A and part B. Let's have a look at Newton's first law of motion. And I have here the balancing nails. And first, Newton's first law of motion, in my words, states, an item at rest will remain at rest until disturbed by an external force. And what is this word force? A force is a push or a pull. For instance, if I pull on this textbook to get it away from the bookcase, I am pulling on it. I am applying a force. Or I can push it and push it back into the bookcase. That pushing and pulling, that is a force. And here, an item at rest will remain at rest until acted upon by an external force. This is my interpretation of Newton's first law of motion, part A. I am an external force. I'm going to come along here and apply a force on this, and it moves. And there it is, Newton's first law of motion. It will remain at rest forever until something comes along and disturbs it. In this case, I am applying a physical force on it, and it's moving. But forces don't necessarily have to be me. They can be invisible forces. Gravity is an invisible force, and Newton is also credited with the discovery of gravity. And gravity always pulls us down towards the center of the earth, and that is something for another video. Magnetism is also a force. I have here a magnet. It has an invisible force, magnetic field around it. And now you can notice right here the item has come to rest. So it is following Newton's first law of motion. It will stay this way until it is disturbed by a force. And in this case, I'm going to use a magnet. Magnetism is a force. And here we go. I just love this. And I can speed it up using the magnetic field. Of course, I went a little bit too far that time. And we'll just put this back together again. There we go. And we'll use magnetism to get this thing moving one more time. I just love this. But we have to move on to part B of Newton's first law of motion. Okay. And part B states, an object continues in motion in a straight line. An object continues in motion in a straight line until it too is affected by an external force. For instance, I'm going to leave this here. And here is an object traveling in a straight line obeying Newton's first law of motion, part B. Oh. Having some technical difficulties. And we'll do that again. Here we go. An object moving in a straight line at a constant speed will continue to move in a straight line at a constant speed until it too is disturbed by an external force. Something stops it. I'll do that again. And the item needs to travel at a constant speed. It can be going slow, at a constant speed, real slow, in a straight line, or it can be going rather quickly. The speed that it's traveling at doesn't matter. What is important is that it has to travel at a constant speed, not speeding up and slowing down, but at a constant speed. And this is obeying Newton's first law of motion, part B. Here it is again. Every object continues in a straight line unless it is forced to change that state by forces acting on it. And it's also in a straight line at a constant speed. Just to do a quick recap, Newton's first law of motion, translated from the Latin, every object continues either at rest or in motion in a straight line unless it is forced to change that state by forces acting on it. And this is physics.